Beautiful sunny day, fall day here. Welcome everyone. Today we're going to be talking about our journey over the last 4 or 5 years in terms of energy efficiency. And Angela, after introductions, is going to do a little bit of a poll. So let me first introduce my two co-presenters today, and then we'll do the poll.
Hello, everybody. I'm Cristiana Figueroa. I'm also working here at, as Hugh said, at the Southwest Regional Office of Department of Ecology. And we have a unit that works pretty closely with facilities on a variety of issues, definitely including energy efficiency.
Hi everyone, my name is Tony Cooper and I'm an engineer here as well. I was with Cristiana and primarily working with industrial facilities doing energy work, hazardous waste reduction, lean work, lean manufacturing type work. And I think with that I'll hand it back to you.
Thanks Cristiana and Tony. Yeah, so we're the State Pollution Prevention Program. We have a P2 planning program, as well as technical assistance in the areas that Tony mentioned, and I imagine like a lot of the state P2 programs across the country. But Angela, maybe you could help us do this little poll. We wanted to ask people just their experience in terms of energy efficiency programs. And can you help us with that? I see there's a poll open. Okay, well, folks on the phone and on the webinar, if you could select your multiple choice answer here. You know, from the top, yes, we've had an energy efficiency program for many years, or yes, we do have a program, but we've recently started that. No, we're looking into it, or no, we really haven't considered it before today. That'd be great, and we'll get to the results of the poll in just a minute or two. So while we're waiting for people to vote, we'll just keep going here and see if we can continue on with our slides. Angela, maybe?
Well, they're voting. Unfortunately, the poll has to be up.
Oh, okay. That's fine. Yeah, I guess I just wanted to mention that, you know, I know some P2 programs have had energy efficiency programs going for decades, probably 25 years, 20 years in some cases. And in Washington State, you know, we're really more in the, you know, I would have probably picked the second box. We've recently started a program. So even though we're somewhat of the rookies, you know, we're going to be doing some of the presentation today, but we'd love to hear from some of the veteran programs a little later on after we're done with our slides, and we'd even love to hear from the folks who are looking into it and considering it, that they might have questions about it. So it looks like so far the results of the poll are showing that yes, folks have had energy efficiency for many years, and that we've got a lot of experience on the webinar. About 54% have, over half have had a number of years experience with energy efficiency. That's great. So let us tell you about our little rookie journey, and then you can share some of your experience with us also. Thank you, Angela. So, yeah, our title today, Washington State's Continuous Industrial Energy Improvements Through Pollution Prevention. And here we go. Trying to get some slides to move and not being successful. Hey, okay. Here's our outline. Kind of our goals and the partnerships that we developed. We wanted to tell you a little bit about those. That was a key component in our journey. We also want to tell you a little bit about some of the tools and capacities that we have and some of the equipment. We'll show you some of that. Some of the lowest hanging fruit opportunities don't even really require much in the way of equipment. And then talk about some of our results, and then we'll have a little bit of discussion. But, you know, really important in this effort has been increasing the capacity, the skills, the knowledge of our staff. People have been great here about learning new skills, and really the emphasis was on better serving our customers, because some of our P2 clients who are working on hazardous waste and hazardous substance use reduction, some of them have done a lot of great work there, and maybe the next step for them is energy efficiency, or maybe during times of energy price volatility, they're really wanting to reduce their use of electricity or natural gas. So it was important to the customers that we gain these skills, and we'll tell you a little bit about that. Our goals promote long-term effective energy management so that industrial facilities routinely consider and implement energy efficiency, which leads to greenhouse gas reduction and minimize their costs. As we'll talk about, EPA Region 10 has really been interested in greenhouse gas reduction. That's been a part of the pollution prevention grants for a number of years, and that really helped us get started on this path. So the bottom part there is our goal of at least 2,500 metric tons of CO2 reduced. We've surpassed that goal in each of the years that we've been doing this program. This is just a little bit of a background slide about industrial energy use in Washington. Industry uses about 43% of the total electricity in the state, a little over a third of the natural gas consumed in Washington. And then the pie chart really is a breakdown of Washington State's industrial energy use. The big slice there is a lot of that's the petroleum refineries that we have in the state. And we've really focused on the two 20% slices, the electricity use by industry as well as the natural gas use by industry. And then about 15% biomass. We've gotten a little bit into that with some industrial boilers and things like that. And then a pretty small slice in this state for coal. Now, this kind of brings up a good point. In the Pacific Northwest, we have pretty low electricity costs because of our abundant hydropower, relatively abundant hydropower. And so if energy efficiency program can work here in Washington State, I think it could probably work anywhere, because it's pretty likely that your electricity rates are higher than ours, or your industrial electricity rates are higher than ours. So how did we do this? A little timeline slide here. When we were getting started in 2007, 2008, we're developing partnerships, which I'll talk about in just a minute. We did get a federal EPA grant for this, starting off as a pilot project. We were fortunate in Washington to have most of our pollution prevention program funded by industrial fees through our P2 planning program, so we're a little flexible with how we can use our EPA grant. So I know that some of the small states who have small programs are a little less, a little more resource constrained. In 2009, we formed our energy efficiency team, or our E-team. Did quite a bit of training with those folks. And then we've been working on implementation for the last 3 or 4 years. Each regional office has staff on the energy efficiency team, or E-team. We've been doing what we're calling screening level assessments. We're not the way deep in energy efficiency experts, but we know enough to see some of the good opportunities and can work with folks on identifying those and costing those out and getting them started in implementation. And you'll see some of our instrumentation that we have in just a minute. I wanted to just kind of pause on the successes and challenges. We'll talk about results in a little bit, but some of the challenges, and hopefully those folks on the line who've had experience can think about the challenges that they've had. You know, funding for assessments has been a little up and down through Department of Energy and the industrial assessment centers, as well as the state energy programs. In fact, we had an industrial assessment center go away. University of Washington had an industrial assessment center that they did not renew the contract, about 18 months ago or so, 2 years ago. And that was certainly a blow to the ability to do assessments here in Washington State, but we have other resources that we'll talk about. Certainly, building awareness with facilities has been important. You know, they see us as the toxics experts, chemical experts, and now we're trying to make sure they understand that we can do energy efficiency work. That's been a little bit of a challenge. Of course, marketing and sales of our services is always something of a challenge, although we've got people who are really good at just building relationships, building trust, and that goes a long way to making those relationships work and making this kind of service work. The volatility of energy prices, as I mentioned too, when prices go way down, folks aren't quite as interested as they were when prices are way up. And then something that Cristiana reminds me of frequently, assessments are great, costing things is great, but then oftentimes, especially when there's new equipment involved in getting into a facility, there's an engineering design phase that's really important, and sometimes funding for that phase is not to be found, or there's not enough support really to help industry get through that phase of it so they can get all the way through implementation and measure results. So we'd love to hear about your challenges at the end of the slides. So partnerships are very important to us. Again, we're not the end-all, be-all experts, and so we rely on these partnerships very heavily. Washington State University is, I think, them as kind of our primary partner in this area because they're sort of the go-to people. They're the state energy office, and they have industrial energy program with the ability to do really in-depth assessments, and we rely on them a lot. We rely on them too just to kind of find out who all is in the energy world. If you ever look at a map of utilities in Washington State, you'd see this incredible patchwork of private utilities, public utility districts, investor-owned utilities, Bonneville Power Administration, and it's a little bit of a complex world, and so figuring that out is another challenge that we've walked through. NEA, Northwest Energy Efficiency Alliance, is a regional nonprofit that has been helping us quite a bit with training. They do a lot of good trainings for us. They're really into sort of market transformation, and so they're working on some policies and things at a regional level. Impact Washington is our manufacturing extension partner here in the state. They have a lot of lean expertise as well as business assistance, and we've been working with them quite a bit on our lean and green type offering, which includes energy efficiency. And then I mentioned Washington's utilities, both private and public, that also have been a great, there's a lot of really great rebate programs that incentivize energy efficiency implementation. So now we're just going to talk a little bit about some examples. I just wanted to throw this slide up to show at a food processor that energy is a part of our offering. In this case, we're talking about our engineering efficiency program, which focuses quite a bit on water, wastewater, and some on material handling, but of course energy opportunities are found at most industrial sites, and this one was no exception to that. And so it just fit in really well and provides a fuller service, more savings for the company, and more benefits for the environment. So here's just some numbers on the savings that were identified at Twin City Foods, and in water, in wastewater, in energy. The costs savings were quite substantial here, running from just over $200,000 to a little less than $400,000 for, depending on how many opportunities are implemented at this facility. So our direct energy efficiency assistance, again, we're really something of rookies still. We're doing maybe 10 to 12 facility projects per year. EPA has given us some grant money to focus on greenhouse gas reductions. What we do primarily is meet with facility maintenance staff and environmental staff or energy staff at the facility, review the utility bills, and just try to help them really move toward the next step or two in terms of energy management. And just a little bit on ecology services, again, what those screening level assessments are, primarily looking at compressed air, doing a compressed air survey, what number of leaks do they have in their system, how large are those, how much is that costing them, using our infrared camera to look at cold storage units, ovens, motors, etc. with that camera, and those are some really nice colorful pictures that we'll see here in a moment. And then really sort of pointing the customer, the facility to the tools that are available, what rebates are available. Some cases their rebates are up to 70% of the equipment costs. Checklist, other experts if there's more in-depth assessment needed, and doing referrals to our partners that I mentioned. So with that, I'd like to hand it over to Cristiana to take us through the next few slides. Cristiana.
Thank you, Hugh. So one of the primary tools that we have found quite helpful in the field is an infrared camera. And the uses that we've found for it, and actually that our facilities have found use at their sites, have been not only identification of greenhouse gas reduction opportunities, but also maintenance staff have been quite interested in using this type of tool and integrating it into their own preventive maintenance for finding opportunities to get their equipment to work well the whole time without down time. Then communication for management briefings, and even assisting with process optimization. So here you'll see one of the very typical things that we find often are installation savings just from identifying thermal leaks that have been there for years and years. But when you do look at it through an infrared camera, it becomes really obvious. In this particular case, at a fruit product manufacturing facility, simply taking account and then doing some calculations regarding adding insulation to their feed water storage tank in their piping in their boiler room saved them about $8,800 per year. At another facility, a packaging facility here, we're looking at 2 vacuum pumps. These are 2 separate lines, and you can see the vacuum pump in this particular line is operating around 90 degrees Fahrenheit. This other one here is operating much hotter. They're both on. So there's obviously something with this pump that the maintenance staff hadn't yet realized, and it could have, it could be dirty filters, blockages, lack of oil lubrication, or cooling system not working. But identifying this ahead of time not only saves the energy wasted from operating a pump in this manner, but also saves their any potential downtime from this pump actually failing. Another example that I mentioned earlier is this example of using an infrared camera to really document what the working conditions are for facility staff. It's not just the leak, the heat leaks that result that could be fixed from better insulation, but in this case, at this facility, people had been complaining a lot about the very hot environment that they worked in, and it wasn't really until a picture like this was presented to management, it became just quite obvious that a simple fix of insulating this reactor tank would make a big difference for the people that work right around in this area. And lastly, this is a situation where optimization of a process was aided with the use of our infrared camera. At this facility, looks like meat, but it isn't. It's actually fruit. And they were putting in a new line, and they were having problems with the viscosity of their product. So they wanted to know. We just happened to be there. It was the same day that we were doing our energy efficiency assessment. And since we had this tool around, and they asked us, can you tell us how uniform the product is across the line because we were having problems with this viscosity. So it turned out that they were having quite uniform temperature, and that helped them figure out that their actual problem lied somewhere else. But this was useful to them, and it's a way of assisting facilities that they didn't quite expect, but helped them out. And Tony will talk now about another aspect of our work with leak detection in compressed air systems.
Thanks, Cristiana. So most of you probably are aware of that most facilities have some kind of compressed air system in their manufacturing process, powering tools, sometimes used to clean off materials, powering machines. The other part of the equation that's really important to realize is that compressed air is one of the most inefficient fuel sources, if we think of it as a fuel, since it's powering these types of machines, and because of the immense amount of energy that goes into compressing the air. So when that air then is used throughout a plant and piped and used to move things and power tools, and then it basically can become lost through that system through all sorts of leaks that aren't necessarily thought of as big hazards because it's air. So it isn't necessarily something that if a person hears a leak or can feel something, they might not think much about it because it's a fairly benign error. But since it is so costly and compressors tend to run the entire shift, possibly 24/7 at a facility, and it's so inefficient, it takes so much electricity to compress air, those leaks end up presenting huge costs to the facility over an annual basis. And then consequently, and it's going to vary, of course, where the facility is getting their energy from, but it can present huge greenhouse gas emission issues and what have you. So we've evolved our compressed air leak detections audit that we've provided to facilities, starting out with a more simple probe we're using a UE Systems Ultra Probe 3000. That's a more advanced gun, but the more simple ones are just listening for the leaks using ultrasonic frequencies, and so that helps you identify where they're at. But one other thing we've kind of evolved our system is this new gun allows us to actually measure the decibel reading of the leak, which then we can calibrate using information about the facility, their set point for the compressors, the electricity cost, and operation hours. We can actually convert each leak back to $1 savings per year if it was fixed, and also then convert that to greenhouse gas emissions on a yearly basis. So this was, again, at Twin City Foods. This was part of that multimedia engineering assessment we did there, and we went through the facility and with the ultrasonic leak detector and found almost 62,000 kilowatt hours of energy saving opportunities. That's on a per year basis, which works out to about $2,200 per year, or about 13,000 pounds of CO2 avoidance if they were to be fixed. And the nice thing about these types of, the leaks that we found at these facilities, and not just Twin City Foods, but almost all of them, they all tend to be fairly simple fixes with parts that are already on site in inventory for mechanical maintenance. So they're fairly fast to be able to be fixed. The parts are ready to roll. They're already accounted for capital-wise for the most part. So they're usually next to no capital requirement. It's really just having the time for the maintenance staff to get in there and work on it. Now, in some places like Twin City Foods, where it tends to be working a really hard push during a growing season, and then there might be some downtime later, that kind of maintenance might occur a little bit after the fact. In more typical places where manufacturing occurs fairly steadily throughout the year, that can just happen when the maintenance shutdowns or on weekends, or if there are timed events for maintenance in the evening or something. It can be a fairly fast way to just kind of check away at different maintenance activities for compressed air leaks. What you would have in that previous picture was a threading was where the compressed compressed air leak was found. It was just a threading failure. Probably needed to be Teflon taped or something like that to prevent it from being from leaking. Other places that we find failures almost at every facility are at quick releases, and what's the other thing here? Solenoid valve. Thank you, Christiana. Solenoid valve malfunctioning or T connection failures. Those are very, very common, and oftentimes the ultrasonic leak detector gun will allow us to hear it even in loud manufacturing settings, but on the occasion that manufacturing is shut down but the compressed air lines are still charged, oftentimes those leaks are still, if they're sizable enough, you can actually still hear them and find them just by the human ear. So oftentimes though, even though we can go through and find these opportunities with the compressed air leak detection gun, sometimes it's really, really simple, and it doesn't, and as I mentioned, it might not even require any capital at all. Turning off compressed air to idle machinery that's not being used on given days, or maybe it's not 24/7, maybe it's during an 8-hour shift and then it's off the other hours of the day, is an easy way to save compressed air, save money, and reduce your greenhouse gas emissions. And so, for example, we worked with a manufacturer who had a 3-axis router that was only used some of the days during the week, and just by turning it off, just turning off the air to the unit, it was somewhere between 19,000 and 40,000 kilowatt hours per year, or $1,000 to $2,700 per year. Another really easy opportunity is looking at cooling capacity and making sure it's not oversized for what you're doing. We see this in facilities that I've seen it personally at facilities that work in aerospace. Christiana, do you have any examples of the oversized cooling capacity?
Yeah, well, this one was at, this particular one that I'm thinking of was at, again, that fruit manufacturer, the fruit product manufacturer. They had a huge space that they were cooling, and in the end, they just had a few, they only needed a very small space. So they were able to shut down that huge cooling room and actually do away with their cooling altogether. And it's just something they hadn't really done before, and the savings were substantial.
So I think that links energy, our energy team with lean work for right-sizing process equipment, and at least in theory. And then finally, I mean, Christiana mentioned it earlier, but looking at insulation is a really easy way with the infrared camera to find ways. I mean, insulation is fairly cheap, easy to install, and we'll see a couple of example pictures from our infrared camera gun here in this next slide, this slide and the next one, to show you how we were able to identify it. This was a plastic composite manufacturer, and they were able to, just using the infrared gun, we could tell that the insulation around these oven doors were a spot where heat loss was occurring pretty dramatically. That scale on the right is, 70 degrees room temperature is where the door is about that temperature, but up near the seals it's over 200 degrees. So there obviously the natural gas savings from this could be substantial over a year. Same here. This is the same company, same issues. The insulation around the doors was failing. So with that, I will hand this back to Hugh to wrap up on the slides.
Thank you, Tony. Yeah, I think we just have 3 more slides left. Really, again, we're just getting started. We've got lots of enthusiasm for a relatively young energy efficiency program. But here are some of the results we've had to date in the last 3.5 years, I think. 13,700 metric tons CO2 equivalent reduction, exceeding our EPA goal for our grant. Saving over $1.4 million and reducing close to 28,900 MMBTU per year from natural gas use reduction, and a close to 18 million kilowatt hours per year electricity reduction. This kind of fits into our overall services in many ways, and really in all our services now. In our P2 planning world, we've been doing that for over 20 years. We've had great reductions in hazardous waste over that time, great savings that have been reported through P2 planning, $45 million saved since 2005. The focus there, again, hazardous substance and substance use reduction, but again, energy efficiency is a part of that. It's a part of our TREE team, which is our technical resources for engineering efficiency, the one I mentioned, which focuses a lot on water, wastewater, but now does energy efficiency. Over $3 million saved there over time. Just the energy efficiency projects, 1.4 million saved since about 2008 when we really started this. And energy efficiency is also an important part of our lean and green service that we've been doing since about 2006-07, and there's about $2 million saved there. But really, again, just kind of getting started on the energy efficiency. But we've been doing a good job, and Cristiana has really been our team lead in terms of incorporating this service, especially into the P2 planning world, and making sure folks are looking for those opportunities when we're out looking at chemicals and gathering those important data and important results to be able to report back to our grantees. I think the two messages I want to just leave you with are, take the time to, for those folks who haven't gotten started yet, to build those partnerships and to understand the different players in your energy efficiency world, to nourish those partnerships. And then lastly, hire great people like Tony and Cristiana who have the desire to learn new skills and provide great service to customers. That's really been a key for us, and we've got people all around the state, not just here in the room today, but all around the state who are learning new stuff and able to transmit that into benefits for the customers. Angela, with that, I'd love to kind of open up the line if we could, or to see what questions we have in terms of folks who wrote in questions.
Great.
How do you want to work that part of it?
Well, I've never done this before, but if folks want to ask a question and they raise their hand, I will unmute them. So if you have a question.
I can certainly, the ground for questions is quite broad, I'd love to hear from other folks what kind of challenges they've had with the veterans in their programs and how they've addressed them in terms of partnerships or funding or building staff capacities or meeting customer needs. I'd also be interested in hearing what's next in terms of energy efficiency. Department of Energy is changing the way they're funding programs, and they've got this advanced manufacturing office. Obviously, there's been a lot of technology improvements in terms of equipment and sensors and data and how to analyze and use that. So also just interested in kind of what other needs do state P2 programs have. Do they have training needs? How might we collaborate or share experiences? Angela, maybe you can tell me if NPPR has a work group devoted to, or has energy efficiency a part of one of the work groups of NPPR?
It has in the past been the Research, Technology, and Energy work group, but unfortunately that work group has not been active. So I think we just had someone step up and say they would be willing to be a co-chair on that, so hopefully that group will become active again. And so This would definitely be some great topics to bring back for that work group to work on. We have a couple comments and questions that have come in so far. I haven't seen any hands go up yet, though. Off-Pacific E2 topic, but would love to learn more about how industry helps with P2 funding.
How industry helps with P2 funding?
Yes.
Well, in this state, our legislature set up the P2 planning program modeled after Oregon's and somewhat related, modeled after Texas's, I think, was to have industry pay fees based on the amount of hazardous waste they generate, the pounds of hazardous waste they generate, and also the pounds of TRI emissions, toxic release inventory emissions that they have. So those fees in part help to fund our program, and maybe that's what the question's about, so that we're not reliant so much on EPA grants. So the EPA grants that we get, we can use them to essentially try new initiatives like this energy efficiency service that we started.
And the next question, please discuss the cost and training involved with the IR camera and ultrasonic probe.
Some of the costs for training we were able to get through NEA, the Northwest Energy Efficiency Alliance. They helped us kind of get started. They were also helping train the manufacturing extension program here, and we kind of, somewhat at the last minute, kind of jumped on board to that training, and that was very helpful. But I'll let somebody else tackle the equipment training piece.
Well, yeah, actually, our IR camera is kind of a mid-range camera. When we bought it a few years back, it was around $6,000, but I believe the price has gone it's gone down quite a bit. In terms of training, the ITC, which is it's a training center that's available for this type of technology, for infrared technology. They offer trainings that are expensive, I believe in the vicinity of $2,000 or so per person, and it ends up with a certification. However, only one person in our group actually has gone through that. Everybody else in our group has received just training from that one person, so train-the-trainer sort of approach. And then really that has been our primary way of training with regards to the IR camera. And then with regards to the ultrasonic leak detector, again, we did have the representative from the manufacturer, the UE representative, come and work with us on the instrumentation for a little bit, but it's been a lot of learning as you go for us. Do you want to add anything to that?
Was it NEA that we did the training with at Steelscape? Who led that? I believe it was NEA, but we did do, again, going back to what Hugh was mentioning, we did team up with NEA, and they led they brought in somebody to do a one-day training, but it was kind of a combined training / survey for a company in our state that allowed a whole bunch of people on the E-team to get some hands-on experience with the ultrasonic leak detectors at a facility while providing a service to the facility at the same time. And so it was actually great on a lot of levels because it gave us the training we needed, gave us some theoretical background into just the physics of compressed air and the energy usage of it, and then it gave us an inroad to the facility that we work with all the time on other things, but it gave us the ability to show that we have the service that we provide, and then gave us the ability to link up with them on a more regular basis every year or so to actually go back and redo the energy assessment so that we can continually improve their usage of compressed air at the facility.
What was the cost for the actual ultrasonic detection probe? Do you recall?
Yeah, it was about $3,500. We have two now. The first one that we got was the very basic model, and then we upgraded. So the basic model was around $1,000, and then the newer one was around $3,500, in that range.
Christiana must have found the IR camera on sale, because I remember having to convince our management it was a good idea to buy this, and somehow it was less than $5,000, because I remember I had to do like my firstborn or something would have to over $5,000, but fortunately the number started with a 4, so we were able to get that.
And the main difference, Angela, did you have something to add?
No, just another question, but go ahead.
Oh, I was just gonna. And the main difference on the ultrasonic leak detector guns in the price point is really the ability to turn the leak size the noise level, the decibel reading, into a leak size, and then into an actual cost savings. The cheaper model works really well for helping you identify the leaks, but that's where it kind of ends.
Great. And could you talk about the calibration needs?
Yeah, sure. So the IR camera can only be calibrated by the factory. And so at this point in time, we haven't seen the need to send it back for calibration, but that is a cost that we will be incurring if we start noticing that there's something really wrong with our readings. For the type of work that we're doing, unless the camera really had, like, it fell and something like that, it would probably most likely keep its calibration for quite a while. With regards to the ultrasonic probe, it again is factory calibrated, and we have not had to calibrate it, send it back to the factory. And do you want to add anything to that?
Nothing other than the probe itself. The ultrasonic probe has tips that are, if something were to happen, the tips are replaceable. The actual sensor tips are replaceable. So if there were a calibration issue, or again, the gun was dropped, I'm clumsy sometimes, so it would be easy enough that we would incur a cost for having to fix the actual sensor tip.
Any other questions? Anybody have any comments they want to go through audio? I can unmute you if you raise your hand. I know there's several folks on the call right now that do have long-running energy programs.
Angela, do you care to say who that person was who wanted to co-lead a new or reinvigorated work group that included energy efficiency?
I want to wait until we get everything figured out first.
Sure.
Because
just know that we're interested, I think, in participating at some level there.
Great, great. Yeah, that would be a good comment to make to Ken, by the way, because we need to look at work.
Upstairs, Angela. Jeez.
Get some more questions coming in. Discuss how your program is intended to fit into the large world of for-profit energy efficiency consultants.
Yeah, that's a good question. Cristiana sounds like she's got some.
Yeah, we actually, we have, there is so much work in this area that we have actually been feeding, in some cases, I can think of at least 2 cases where we were actually trying to find someone that would do an engineering design for implementing one of the opportunities that we had zeroed in on. So there hasn't been any competition at this point in time in terms of the private-public issue. Actually, it's kind of quite been the opposite. Industries have been grateful that we have come and shared some new ideas around how they can save energy. And then when we have needed an in-depth assessment, I'm not sure how it is in the rest of the country, but in this area, as Hugh mentioned, we do have the Energy Extension Office at Washington State University that can do a very in-depth assessment for specific systems if that's what's needed, or utilities have also, in certain situations, especially when there's capital investments involved, will go and spend some funding and actually pay for a more in-depth assessment if needed. So really there hasn't been any dichotomy whatsoever.
I think that's a good point in terms of, sometimes people are concerned about the competition of the public sector, but really we're out there identifying opportunities primarily, and then trying to help facilities take the next couple steps toward implementing that opportunity, or really getting the equipment and the practices they need in place to achieve reductions. And that's where the private sector can really help out, and that we can really tee up opportunities for the private sector to come in and do either a assessment or design phase, or wherever the facility needs help to really get that project all the way through to completion. What do they call those? Energy service contracts. Mm-hmm. Those can be really useful too.
Energy service providers. Yeah.
How are we doing, Angela?
Good. We have several more questions. Do you use interns?
We have not used many interns. We do not have a full-fledged intern program. I know some of the other state P2 programs do have interns. We used, when we had an industrial assessment center, they had grad students and undergrads that certainly helped with their assessments. But, and I just saw a note that Ken's thinking about an intern program, but we haven't used those extensively in the past.
And do you know, on average, how long it took from the time that the recommendations for energy improvement were made to when they were implemented?
Yes, it is. You have to hang in there. It is amazing how long it can take, especially for those that are low-hanging fruit ones like installation. They can happen within a month, a couple weeks, very fast. But anything that requires capital, I've seen 2 years at times, even with rebates from the utility. So, but on the other hand, it's been really rewarding to see that they have in the end come through and actually implemented. It just takes a while.
On the issue of rebates, of course, it's super important to make sure that the utility finds out as soon as possible that a facility is working on an opportunity and is thinking about purchasing equipment. You know, the worst case scenario is the facility goes out and purchases the equipment, goes to the utility and asks for a rebate, and they say, sorry, too late. So just encourage your customers to get that, or do it yourself. Make sure the utility finds out early about the facility and their needs for new equipment.
And on the other hand, on the other end of the spectrum, on the compressed air leak things, I said, earlier on that it's generally pretty low capital, or they have the parts on hand. I've had facilities who are basically following me around and fixing things as I find them, and I don't even have to do a report. So it can be instantaneous almost as well.
Right. Thanks for adding that.
Yeah,
That's a good point.
Good.
Great, thank you. One more question. Please make sure you're typing your questions in the question box or raise your hand. How are you handling confidentiality versus the need to demonstrate the success of the program?
Yeah, confidentiality really needs to be worked out on a facility-by-facility basis. Some facilities are, they all have some confidentiality concerns, and so fortunately, our program does have the ability to provide some confidentiality, and we do that for folks. There's sort of a range of needs, and you have to find that out early. Usually, facilities are pretty upfront about telling you that. Usually, about the time we get to the success story, then we really know where their needs are, because when we send them a draft success story, they say, "Well, I don't want to say X, but I can say Y." So you just have to work through it with the facility, and it's important to do so to maintain your relationships and maintain your trust.
It's definitely a case-by-case situation. Like, some facilities don't want us to use their name at all, or I'm not sure why, but they just have a different, But others would want us to talk about them. So it just depends.
It's also important really to kind of make those agreements up front, so that, because people change jobs, and we had one case recently where a facility worked with us and even did a video, really nice video testimonial. Then the plant manager changed. The new plant manager came on, didn't really know what had been done at the facility, and wasn't comfortable given approval for that video, and right now it's stuck. So if we had done a better job, I think, of getting in writing the approval for that, we'd have a video success story to share, and right now we don't. We want to make sure we work through that with the new plant manager, but important to get those agreements in writing and up front.
Have you been able to get utilities to endorse and or market your program, and if so, how?
Well, actually working through NEA, the Northwest Energy Efficiency Alliance, they helped us with marketing as well. In fact, they created a brochure for us and introduced us directly to the key personnel at a variety of utilities. So now we have relationships with some of our larger utilities, staff at larger utilities, but we also have this marketing tool that we can use with industrial facilities that are located in smaller utilities where we normally don't interact with as much.
Yeah, I'd say the other thing is that was very helpful. I know we even just set up some informal lunches with, or NEA helped us set those up with some of the utilities. It was at one of the regional conferences, so people were already there, and I think that was nice for NEA to do that and invite people to lunch so we could just talk and meet each other. I think, attending some of the regional or statewide conferences has been helpful, just again to get to know the players. They see your face, you remind them, oh yeah, Department of Ecology has that energy efficiency service, that's why they're here. Oh yeah, they're interested in greenhouse gas reductions, and they've got people who know how to use the IR camera and the leak detectors, and there they are again. So I mean, you do have to sort of remind people that you're out there and kind of stay in touch with the latest developments, and part of that is showing up at events.
Thank you.
Great, thank you. Just a reminder to everyone, please remember to take the evaluation at the end of the webinar. As you exit out, the evaluation will automatically pop up. Please take a couple of minutes to fill that out. And that is the last of our questions. So I'd like to thank our presenters today, Hugh, Cristiana, and Tony. And again, reminder for folks to do the evaluation, and the slides will be posted on the NPPR website, p2.org, on Tuesday next week. Thank you everyone for attending today.
Thanks, Angela. Appreciate it, and thanks everybody for participating today. If you have other questions, you can certainly email us or call us at the numbers provided. Thanks, NPPR.
Thanks. Bye.
Bye.
Bye-bye.